All right, so various variations. What you're looking at, students will be writing some direct and inverse variation equations, and we'll see how that works here in a second. First of all, you'll notice that at the top, you have one problem. It says that a square with a side of x units has a perimeter of y units. We have to come up with an equation that would describe this particular situation. Well, first of all, how do you find the perimeter of any shape? What's that? Add it all together. Add what together? All the sides, okay? Now remember, we are talking about a square. So this right here is x. What are all the other sides? They're also x. So all of these are x's. So if I wanted to find my perimeter, which we're calling y, what am I going to have to do again? Add up all the x's. So x plus x plus x plus x. Well, we can simplify that, make that look a little nicer there. Rather than x plus x plus x plus x, we can also write that as what? 4x. 4x. Why? Because there's 4 x's. So this equation would describe the perimeter of this particular rectangle. Now we're going to use this equation to fill out this table over here. Now remember, the x's represent the length of the side. The y values represent the perimeter. So the first thing we want to know is, if we had a side of 3, what would the perimeter be? Well, let's use our equation here. What do you get when you multiply 4 times 3? 12. So in other words, if each side was a 3, a length of 3, the perimeter there would be 12. Let's try the next one. Pull out the calculator. 7.5. What if each side was 7.5? What would the perimeter be? Well, multiply 4 times 7.5 and you get a 30. Let's do the next one. Again, I'm looking for the y, the perimeter. Well, what if each side was 9.5? What would the perimeter be? What's that? 38. And again, all we're doing is taking each x value and multiplying it by 4. There's 4 sides. All right, so there's the first one. Our equation was y equals 4x, and we can use that equation to fill out the table. Now let's take a look at the next one, number 2. This time we have a rectangle, and this rectangle has a length of x units. That's this piece over here. And a width of y units. That's this piece over here. It says it has an area of 60 units squared. So it could be inches, feet, we don't know, we're just saying units. All right, so let's talk about area. How do you find the area of a rectangle? Length times width. So in our case, we would be multiplying the x times the y. Now since we know the area, when I multiply that x and y, I get a 60. So whatever those two values are, when I multiply them together, they equal 60. All right, so this is the equation we have here. However, usually when we write our equation, we like to have them say y equals. So I want this one to say y equals. So what do I need to do if I want this one to say y equals x? Okay, so how are we going to move the x? What are they doing to the x and the y right now? They are multiplying. So what's the opposite of multiplying by an x? Divide. Okay, so now we have 60 divided by x. Again, let's not forget, y is going to represent the width. X is going to represent the length. We know the area is 60. So let's fill out the table. The x values, again, they represent the length. We're looking for the width. All right, so we have 4. 4 for our length. What's 60 divided by 4? 60 divided by 4 would be a 15. What if we had a length of 8? What's 60 divided by 8? 7.5. And what if we had a length of 12? 60 divided by 12 would give us a 5. Now I want to point something out. Notice we said over here that the length times the width was equal to 60. And regardless of which order pair I choose, look what happens when you multiply those two numbers together. What do you get when you multiply 4 times the 15? You get that 60. What do you get when you multiply 8 times the 7.5? You get the 60. What do you get when you multiply 12 times 5? You get the 60. Okay, so let's not forget about that. All right, number 3. Number 3 says there's a man that's 5 feet tall, and he casts a shadow of 3 feet. At the same time of day, there's a tree, which we don't know the height, so we're calling it Y over here. We have no idea how tall the tree is. And it also casts a shadow, which again we don't know, so we're calling it X. And we want to write an equation that would describe this situation. Now, if you look closely here, we're dealing with 2 similar triangles. We got this triangle here and this triangle here. And because they're similar triangles, we can create a proportion. All right, so we're going to create a proportion based off of these 2 triangles. So I'm going to take the big triangle here. First thing I'm going to do is write a ratio or a fraction. I'm going to take the height of the tree, which we're calling Y, over the length of the shadow, which we're calling X. What we're going to do is we're going to set that equal to the smaller triangle. Now remember, my top number was the height of the tree. So in this case, the height of the person is 5 feet, so it goes on top. This X down here on my first fraction represented the shadow. The shadow of this 5-foot person is 3. So here's the equation we have. However, when we write an equation, we like for it to say Y equals. All right, so if I want this one to say Y equals, right now they're taking Y and dividing it by X. What's the opposite of dividing by X? Multiplying by X. So now I'm going to end up with the equation 5/3 times X. So my equation now is Y equals 5/3 times X. Remember, X represents the length of the shadow. Y represents the height of the tree. So now let's use this equation to fill out the table. Now notice the table over here, what we're doing is we're looking for the height of the tree. We're given a couple of different shadows, lengths, and we want to find the height. So here we go. 4.5. If we had a shadow of 4.5, what would be the height of our tree? Well, let's use our equation that we just came up with. 5/3 times 4.5. What's 5/3 times 4.5? Put it in your calculator. I got it yet? 7.5. Put that in your table. 7.5. So in other words, if this tree casts a shadow of 4.5 feet, we're going to end up with a height of 7.5. What if the shadow was 9 feet? Well, let's find out how tall the tree is if the shadow is 9 feet. Use that same equation again. 5/3 times 9. What's 5/3 times 9? 15. 15. So again, if the shadow is 9 feet, the tree is 15 feet tall. Let's do one more here. 10.5. What if the shadow was 10.5 feet? How tall is the tree? Use your equation again. Like that? 17.5. So if you look closely there, it makes a little sense there. If you have a real long shadow, the tree's going to be pretty tall. If it's a short shadow, it's probably not that tall. All right, going on to the next one here, number 4. Here we have a person that's 60 inches tall, and he's looking at a mirror that's 30 inches away from the wall. So that's this part right here. That's that 30 inches they're talking about. If she is X inches away, here's the X inches away, we want to know how far Y up the wall can she see. This part right here. Now remember, we know how tall she is. She's 60 inches. We know this piece over here is 60 inches. So again, we want to set up an equation that would help us find the Y values, which in this case is going to be the height up the wall that we can look. So it's kind of like the one we did earlier with the tree. We're going to set up a proportion. We've got 2 triangles. We've got a small triangle, and then we've got a larger triangle. So I'm going to start over here with the smaller triangle. The height up the wall is represented with a Y. The distance away from that mirror is 30 inches. So there's my first fraction, Y over 30. I'm going to set that equal to another fraction, and I'm going to get that other fraction from the other triangle that's created with that person. So the question is, what am I going to put on the top of my fraction? 60 or the x? 60. It's the height. Just like the height of the wall over here, the height of the person is 60, which obviously means x would go down here at the bottom. All right, so there is my equation. But again, I usually like to have it say y equals. So I want this thing to say y equals. So how are we going to make it say y equals? Well, look what they're doing to the y. They're dividing it by 30. What's the opposite of dividing by 30? Multiplying by 30. So if I multiply this 60 times that 30, what's 60 times 30? 60 times 30. What's that? 1,800 over x. Of course, we still got that x as our denominator. All we did was multiply the 60 times the 30. All right, so this is my equation. Y equals 1,800 divided by x. Again, x represents how far this person is standing away from the mirror. Y represents how high up the wall she can see. So, x, if x is 20, if she's standing 20 feet away from the mirror, how high above the wall is she going to be able to see? Well, what's 1,800 divided by 20? Use that equation. 1,800 divided by 20. 9. 40. What if she's standing 40 feet away from the mirror? 1,800 divided by 40 would be 45. 60. What if she's standing 60 feet away from the mirror? 30. What are you noticing here about that table? You notice anything? The further back she moves, what's happening? Yeah, the smaller that y value gets, which means she can't see as high up the wall. So the further you are back, the less you're going to be able to see on that wall. All right, number 5. For x people to travel, the cost, and we're going to use y to represent the cost in dollars, for renting a bus is $7 per person. Again, we're trying to write an equation that represents this situation. So y represents the cost. Y represents the cost. So how exactly do we find the cost? Well, they're telling us that $7.50 is what they're charging per person. And we don't know how many people are going, so we're using x to represent the number of people going. Therefore, we can have the equation 750x. Again, 750 represents how much they're charging per person. X represents how many people go. So let's use this equation to fill out our table. Remember, x's represent how many people are traveling. Y represents how much it's going to cost. So if 10 people go, what is it going to cost? What's 750 times 10? 75. It's going to cost $75. What if 25 people go? 25 times 750 is 187.5 or $187.50. What if 30 people go? 225. So this is what it's going to cost if we have 10 people going, 25 people going, and 30 people going. And we can find these values by using the equation y equals 750x. All right, number 6, it says here that the bus will cost $180 to rent. So we're going to rent the whole bus. It's going to cost $180. If X people ride, how much will it cost per person? How much will it cost per person? All right, so here we go. Again, y and x. If I multiply y times x, x being the number of people, y being how much I'm charging, I know when I multiply those together, it needs to equal 180. That's what it costs to rent the bus. It costs a total of $180 to rent the bus. But again, I like my equations to say y equals. So let's make this say y equals. So notice what they're doing to the y is they're multiplying it by the x. So I'm going to do the opposite. I'm going to divide by x. So now we end up with 180 divided by x. Again, x is representing the number of people going. Y is representing how much each person is going to have to pay. So let's figure this out here. 4. If 4 people go, how much is each one going to have to pay? Well, what's 180 divided by 4? 180 divided by 4.
45.
What's that? 45. 8. What if 8 people go? What's 180 divided by 8? 2250. So each person would have to pay 2250. What if 12 people go? $15 apiece. So obviously, the more and more people go, the less you're going to have to pay. Makes sense, right? So we've worked 6 different problems here. Got 6 different equations. Now we're going to take a close look at that. So if we look at the last part here, we're going to start by taking a look at numbers 1, 3, and 5. Notice up here it says, what do problems 1, 3, and 5 have in common? So right now we're only looking at those 3. 1, 3, and 5. I want you to look at 1, 3, and 5. First of all, I want you to look at the table for 1, 3, and 5. So let me go ahead and bring mine down over here so we can take a look here. And remember, we're looking at 1, 3, and 5. That's the one with the square, that's the one with the tree, and that's the first one on the bus here. I want you to look at the tables. Look at the tables. We're going to look for some kind of pattern within these 3 tables. I'm looking at this table here, and this table here. So, over here it says, if X blanks, then Y blanks. What do you notice about the table? As the X's do what? The Y's do what? As the X's increase, notice how the X's are getting bigger as we go down the table. What's happening to the Y values? They decrease. So write that for me in the blanks here. As we increase the X values, the Y values decrease. No, they don't decrease. Increase. Looking at the other one. Alright, so as the X's get bigger, so do the Y values. They both get bigger. So right underneath that relationship, the X and Y values have a constant blank. They have a constant, what we call, let's see here, ratio. Or we can also call it rate. Same thing. You can have a constant ratio or a constant rate. So on this first example, the constant ratio or rate was a 4. On number 3 here, the constant ratio or rate was 5/3. And on number 5 down there, the constant rate or ratio was the 750. It was always the same thing over and over and over. We were multiplying by a 4. We were multiplying by 5/3. We were multiplying by a 750. It was always the same thing. It had a constant ratio or rate. Now the equation here, look at the equations that we ended up with. They were always in the form y equals some number times the x. Some number times the x. And that some number, I'm going to let it be represented with a k. So, in other words, it was always in this form. It was always y equals a number times an x. On the first one, it was y equals 4x. On the second one, it was y equals 5/3 x. On the last one there, it was y equals 750x. And so the only thing that changed on these equations was the value of k. It was always some different number. All right, term. We call this a direct variation. Direct variation. Called a direct variation. So a sample, which is what you guys are going to be working on today, is if y varies directly as x and y is 12 when x is 8, then what is the y when x is a 24? So here's how you're going to do it. You're going to be getting a couple of these here in a minute. They're telling us that we know that the y value is 12 when the x value is 8. So if that's the case, then what's the y value when the x is 24? Well, we're working with a direct variation. So here's how you're going to do it. Make sure you're writing this down because, like I said, you're going to be doing a couple of these here in a second. So on the first one, we have no idea what that constant is, that ratio. So we have to find that k first. So here's what they told us. They told us that the y was a 12, and they told us that the x was a 8. This is what they gave us. So what I want to know is, what was that constant ratio? What is that k value? Well, let's find it. We can do that. If I want to know what k is, all I got to do is divide by 8. So what do you get when you do 12 divided by 8? 12 divided by 8 is 1.5. So now we know what that constant ratio is. So now we can actually answer the question. So let's do this again. Here's the equation that we're using because we are talking directly. What we're looking for is the y value. We know what the k is now. We know that it's 1.5. We just found that. They told us that the x value was 24. So if that's the case, what's the y value? Well, what do you get when you multiply 1.5 times the 24? 1.5 times the 24 would be a what? 36. 36. Like I said, you'll be getting a couple of those here in a minute. All right, so let's do the same thing with the other three. Let me get this out of the way. On the other side, it says, what do you notice about problems 2, 4, and 6? All right, let's start by looking at the tables first. Everybody look at your tables on 2, 4, and 6. As the x is blank, the y is blank. What do you notice about the tables there? There you go. This time, as the x's increase, the y values decrease. They're getting smaller. As the x's get bigger, the y values get smaller. So this time, the x and y value have a constant product. Have a constant product. In other words, if you look closely at your tables there, when you multiply those two numbers, the x and y value, you always get the same thing. So if you look at number 2, everybody look at number 2. Look at the first order pair we have. 4 times 15. What do you get when you multiply 4 times 15? 60. What do you get when you multiply 8 times the 7.5? 60. What do you get when you multiply 12 times the 5? You get a 60. They always have a constant product, meaning when we multiply them, we always get the same thing. Look at number 4. Look at the order pairs there. Notice what happens when you multiply 20 times 90. What do you get when you multiply 20 times 90? 1,800. What do you get when you multiply 40 times the 45? You get 1,800. What do you get when you multiply 60 times 30? You get 1,800. And so when we're multiplying the two numbers together, the x and the y, we get that constant product. Same thing for number 6. Notice what happens when you multiply the two numbers on number 6. 8 times 2250 ends up being 180. When you multiply 12 times 15, you get 180, and so on and so on. All right, so the equation here, actually there were two different forms that we have. We have this one, x times y equals k, or we also changed those so that we had y by itself, which was y equals k over x. Which this is the one we're going to stick with right here. Y equals k over x. The term we use for this equation is inverse variation. Inverse variation. So this one was direct, this one is inverse. Notice how the equations are slightly different from each other. This was y equals k times x. This new one we have here is y equals k divided by x. All right, so if y varies over here inversely as x and 12, or y is 12 and x is 8. And what is the y value when the x is 8? 24. We're going to do it very similar to what we did over here. The only difference is we got to use a different equation. The equation we're going to use now is y equals k over x. This is the inverse. All right, so you'll notice here they gave us the y value of 12. They gave us the x value of 8. We need to find out what is that k. So that's what we're going to do first. So I've got 12 equals k divided by 8. So all I've done is replace the y and the x with a 12 and an 8. We need to figure out what the k is. And to do that, very simple. Notice what they're doing to the k is they're dividing it by 8. So what's the opposite of dividing by 8? Multiplying by 8. So 12 times 8 would give us a, what's 12 times 8? 96. We now know the k. We know that it's 96. Now we can come over here and actually answer the question. So here's the same equation, y equals k over x. We are looking for the y value. We now know that the k is a 96. They told us that the x value was a 24. So if I go ahead and divide 96 by 24, what is 96 divided by 24? 4. All right, so our x value is 4, or the y value is 4, when the x value is a 20. And we can find that by using this equation, y equals k over x. So we're going to have to pay real close attention to whether we're working with directly or inverse variation. So that'll determine which of these equations to use, this one or this one. All right, so that takes us to various variations. I'm going to give you a chance to do some on your own now.